Very good morning to all. So today we will start our class with types of fluid flow. So previously we have studied about different types of what is fluid, how fluid is in stable condition, how does it work. Now fluid flow depends on fluid motion. Okay. So let's first be clear. Fluid should be under motion. So as we see in previous cases, we have learned for how fluids are stable at a different height, how fluid is stable inside some pipe or something. But now we will go for fluid motion. So fluid motion is of different types. So let's go for types of fluid. Whenever inside pipe, whenever fluid is flowing, it is characterized in different forms. Like sometimes it may be stable, sometimes it may be flowing in a straight way, sometimes it will be flowing in turbulently. So sometimes we can compress the fluid, sometimes we can't compress the fluid. So there are different types of fluid with which we have to deal with. Okay. So first type of flow is one is steady flow, and opposite to it we are having unsteady flow. Okay. So we know this steady flow and unsteady flow depends on different types of fluid characteristics. So what are the fluid characteristics? We can say fluid characteristics. By studying whom we can differentiate between this steady flow and this unsteady flow. What are the fluid characteristics? Now they are velocity, pressure and density. Correct. Now velocity, pressure and density. What are different fluid characteristics we have already studied? Okay. So velocity means the speed with which the fluid flows with respect to time. If this is a pipe inside which our fluid flows, then with respect to time means say this is of L length and this is suppose this point A to point B, the fluid covers for 1 second. Correct? So we can say the distance covered per unit time is known as my fluid velocity. Okay? So now the velocity phenomena we have understood, which is one kind of fluid characteristics. Next, pressure. Pressure means what? The force of liquid per unit area. Whenever if this is the same pipe, the force applied by the fluid or this unit area, say suppose I am considering this plate. There is a plate or small section. The force applied by this much quantity of fluid per unit area is known as pressure. So this is we have understood velocity. Now we have understood pressure. Now let's go for density. What is density? We know mass per volume is known as density. Now mass means again the mass of water getting inside this pipe and mass of volume. How much volume it occupies, that is known as density. So the mass per unit volume is known as density, which is signified by rho. So now we can say that these are different type of fluid characteristics depending on which we can differentiate between unsteady flow and steady flow. So we say if we can write like this, we have to write steady flow at this side and unsteady flow at this side for better understanding. So now we can say the flow is called as steady flow if the fluid characteristics do not change with time. Here, the fluid characteristics do not change with time. Means the steady flow means whether there will be if there is a pipe from where the liquid has to be passed from point A to point B to point C, from starting to ending of the pipe, the flow, the characteristics means the velocity, the pressure, the density. All three of them do not change. They don't change at all. Okay? So here, if it is versus means the opposite thing will happen. That means here the fluid characteristics what? Change with respect to time. Okay? So, if we express the steady flow mathematically, because we know everything we can derive in mathematical forms. So, if it is changing and if do not change, if it don't change, means the mathematical derivation of everything, every characteristic should be zero. So, if it is not changing, the mathematical derivation of something will not be equal to zero. So that means what? This del by del t of something. What is that something? That is the characteristics. Should be equal to zero at one case and should not be zero at one case. Okay? So in steady flow, we can write down mathematically. If this thing we can express, the mathematically we can say del P by del T, then del P by del T and del rho by del T. These are the three properties we are taking. Now what are the equations? See, whenever a fluid is flowing, it is flowing along all the three directions. If this is the axis, we can say this is for x-axis. This is for, so suppose it is x0. This is y-axis, suppose it is y0. And this is the third dimension called z0. Let's say the fluid is flowing. So, this is the point A suppose. Okay? So, if we are considering the fluid flow in a pipe and we are trying to form an equation of steady flow into it, so we have to go for velocity in all the three directions. And all the three directions are which directions? x0, y0 and z0. Correct? Here also the same thing. x0, y0, z0. Here also the same thing. What is that? y0, z0 should not be equal to 0 because the fluid characteristics change with respect to time. They are not constant. If they are here, the fluid characteristics don't change. If they don't change, they are constant. So every variation is 0. dv by dt means variation with respect to time of the characteristics. If it is constant, then deviation is 0. So this is the equation. With respect to velocity, deviation is 0 because it is constant flow. So your pressure deviation with respect to time is 0 because it is flowing constantly. So pressure is also uniform. So deviation d by dt with respect to pressure is 0. Again, d rho by dt means density also don't change because nothing changes here from starting point to ending point. So every deviation is 0. But here deviation is not equal to 0. Little bit deviation always happens because it says that the fluid characteristics change with respect to time. So d by dt means deviation of any characteristics with respect to time in all the three directions cannot be equal to 0. There must be some changes. There must be some changes. So this is equal to 0. Again, second equation is, as in second equation is here, dp by dt along all the three directions x0, y0, z0 is not equal to 0. Again, del rho by del t along all the three axes is x0, y0, z0. Okay. So in all the three characteristics here cannot be equal to 0. Why? Because here the characteristics change with respect to time. If change happens, then change means d by dt in mathematical form. Change is d by dt of something. This is known as change mathematically. So this cannot be equal to 0. But here the don't change means the deviation is 0. There. Understood? Now we will go for the next type. This was the type 1. Next we will go for type 2. What is the second type of fluid flow? Okay. One type we have studied here, that is steady and unsteady. Okay. Now second type of fluid flow. What is the second type? The second type is uniform flow and another type opposite to it, non-uniform flow. One is uniform flow, another is non-uniform flow. So what do you mean by this? We should also write it down by differentiating two maps. First is what is uniform flow? Here the velocity at any given time does not change with respect to space. So we can say dv by ds is equal to 0 when t is equal to constant. What does it mean? Uniform flow. What is uniform flow? The velocity at any given time does not change with respect to space. Space means what? If this is suppose a pipe through which the fluid flows. Okay? This is the total space, means along all the three directions. We know this is x0, this is y0, this is z0. So if fluid flows only from that is parallel to y0 only. If fluid flow line of some is in z direction like this, so from point A to point B, the flow line will be along z direction parallel to z0 direction only. So nothing changes. So that's why it is told the velocity at any given time does not change with respect to space. Why this is space time? Because it considers all the three axes. X0, Y0, Z0 means the total space is considered. So from starting to ending, the space concept totally does not change anything from point A to point B. So if total all the three axes are considered, then the volume is to be considered. Because along three directions, what we can consider is volume. We cannot consider the area. Because we have length and breadth and diameter, height, everything will be inserted. Okay, because it will be along all the three directions. So d by ds, that s is space. That is this space. Which space? The space from which to which fluid is flowing. Nothing beyond that, nothing before that. Only the fluid flow space is to be considered. So del by del s means change with respect to space d by ds. Of what? Which direction? Means volume. Okay? Volume or velocity. Okay? Volume through which water flows in a certain velocity. Okay? Velocity means if the water is flowing inside a pipe, it travels through certain volume only. And that volume, speed of that volume of water gives us the velocity. So that's why change of velocity with respect to the space of traveling of fluid at constant time means here if we are considering 1 second, the length we are considering 1 second only, the time always is constant. Here, because we know whenever you are considering an equation, we have to take something constant. So what is that something here? Time. Time is constant. So dp by ds is equal to 0. Okay. So if we write down contrary to that, what will be the equation? What will be the definition? Here, the velocity at any given time change with respect to space. Just opposite to it. That is non-uniform motion. So what will be the equation now? The equation will be dp by ds at constant time should not be equal to 0. There must be some change. Change cannot be 0. And again I am saying, what is the change? d by ds. Change is with respect to space. Here we are taking with respect to space. Okay? So now we have gone for the second variety, that is uniform and non-uniform type of flow. Next what kind of flow? We have already studied. One is steady flow, one is unsteady flow, one is uniform flow, one is non-uniform flow. Now we will go for the third type of flow, which is the third type of flow? in turbulent flow is the opposite. What is that? Fluid particles move along zigzag lines. Along the fluid flow. Okay? So what does this mean? One is laminar flow, another is turbulent flow. See, if we can draw this by a figure, if this is suppose a pipe. This is the axis. Correct? If one fluid from A to B, if one volt of fluids flows like this, it will go from A to B like this only. Means parallel to the axis. Same here, they will flow parallel to the axis. That this is called laminar flow. What is turbulent flow? If suppose again this is a pipe from where fluid is to be flown, they will never go like this. They will go like what? This, again this, again this, again this. They will move like this. So they will cover a zigzag path of this. So now tell me, if this is the laminar flow, if that is the turbulent flow, pressure is high in which case upon the pipe? Obviously in turbulent flow, because laminar flow will be quiet, it will be flowing smoothly. So we can write down difference. Number 2, that is fluid flows smoothly. Correct? Here fluid flow is not at all smooth. Why? Because fluid particles will strike at this point, then this point, then this point, strike with each other. So there is a lot of mess. So fluid does not flow smoothly. Correct? Now again, here parallel flow happens. There zigzag flow happens. Okay. So now next here difference will be based upon one number, that is known as Reynolds number. Before knowing the third difference, let's see what is Reynolds number, which is denoted by Re. Correct? So Reynolds number is the number which is defined for fluid flow. What is that? We can say Re. If we can, this will Reynolds number will derive different types of fluid flow. What are the types? It will be decided by this Reynolds number only. Okay. So what is the equation? That will be equal to V d by rho. V we know, velocity of the fluid flow. D is known as diameter of that particular pipe, and rho is the mass density or density of the fluid upon which it is flowing. So Re is equal to V d by rho. So what is that? If Reynolds number is something greater or lesser than something, then the flow is flowed as laminar flow. If this is the third point, correct? If Reynolds number is greater or less than something, then it may be a turbulent flow. So what is laminar flow? That if Reynolds number is less than 2000, then only the flow is known as laminar flow. Okay, if we calculate Reynolds number. Now this Reynolds number, if we find it is less than 2000, maybe 100, 200, 500, something like this. Then Reynolds number is less than 200, then we can say the flow is laminar flow. The flow is a little bit steady. The line of flow goes on parallel and all that. So this is a sign that if we are getting a fluid and if we want to search for whether the flow of the fluid inside the pipe will be laminar type or turbulent type, what we will do? We will go for the velocity. What will the velocity through which we are going to make the fluid flow inside the pipe? What is the diameter of the pipe? And what is the density of the fluid which is going to flow? So let's first find it out. After that, if we are getting the Reynolds number value, if it is less than 2000, then we can assure, okay, the flow of this little bit of this fluid will flow. This will go for laminar flow. And if the Reynolds number is greater than 4000, what will happen? The fluid will go turbulent. Turbulent means the fluid particles will strike here, there. Means there is a lot of pressure on the pipe. It may go here, there, anywhere it can strike. The bursting of chances of the pipe increases due to turbulent flow. So, if a pipe in which flow of fluid of any density is going, and if the Reynolds number we have calculated is more than 4000, means pipe is in danger. So we have an in between. If we say this is less than 2000, this is greater than 4000, what between 2000 to 4000? If the fluid Reynolds number stays in between 2000 to 4000, then the flow may be laminar, may be turbulent. Depends on different pipe characteristics, different temperature, different kind of things. So flow may be laminar or turbulent. Now we have understood this may come as a 2-mark short question. Okay, what do you mean by Reynolds number? Whenever we are going to describe it, first we should write down that Reynolds number decides the type of fluid we are going to flow inside a pipe. Then inside that we can say if this is the formula where this is this. I have already told this we have to write down. Then we can mention if Reynolds number less than 2000, then it is a laminar flow. Then Reynolds number greater than 4000 is a turbulent flow. And in between 2000 to 4000, it may be laminar, may be turbulent. Okay. So now we are going for next type. What is the next type of fluid flow? Okay, next we go for compressible and incompressible fluid. Okay, compressible and incompressible fluid. In the next class, we have studied 3 types, and next 3 types we will study in the next class. Okay, thank you very much for your patient listening. Now revision and come. Okay, for all the 3 types, go for revision, your Reynolds number and everything, and come to the next class. The